Okay, picture this. Every single year, thousands of totally capable students walk into their Cambridge 0606 additional maths exam, and bam, they immediately step right into a three-move examiner trap. It's this super subtle, almost invisible snare that just absolutely wrecks grade boundaries. It turns what should be a straightforward kinematics question into this massive loss of marks. We're not doing any fluff today, right? We're going to completely deconstruct this trap so you never, ever fall for it in your own exams. So I want you to think of your exam paper not just as a standard test, right? Think of it as a high-stakes chess match against a master examiner. Because, let's be real, they know exactly how you've been taught to revise, and they intentionally leave these tiny, subtle clues that, if you miss them, lead to just devastating mark losses. If you're treating kinematics as just, a bunch of random equations to memorize, you are literally walking into this match blindfolded. So, here's our battle plan for this explainer. First up, the examiner's chess trap. Number 2, kinematic core principles. 3, the procedural success framework. 4, principal examiner insights. And finally, number 5, setting up the checkmate. All right, let's kick things off with section 1, the examiner's chess trap. Let's just dive right in by exposing a really painful mistake. Why does ordinary revision completely fail when you're up against a master examiner? Well, the trap isn't that the math is impossibly hard. It's actually that the examiner is assessing your analytical depth, not just your superficial breadth. Students lose marks because they memorize a formula, but they fundamentally fail to understand the variables themselves. You see, the entire theoretical architecture of kinematics rests on these really precise causal relationships. Velocity, or v, is the rate of change of displacement, s, and acceleration, a, is the rate of change of velocity. These calculus-based connections form your primary defense against the trap. Because if you don't grasp that these are literally rates of change, you're not going to realize when you need to differentiate or integrate based on whatever specific context they throw at you. Moving right along to section 2, kinematic core principles. Now, by visualizing these abstract formulas, you can finally stop just memorizing and start actually reading the physics of the problem. And that is exactly what the Cambridge Assessment Framework demands. So here's your step-by-step procedure. When you need to move forward from displacement to velocity, you differentiate. S with respect to time, so v equals ds by dt. To find acceleration, you just differentiate again, so a equals dv by dt, which is also the second derivative of displacement. But what if you need to move backward? Well, then you integrate. You integrate acceleration to find velocity, and you integrate velocity to find displacement. This whole forward and backward calculus engine, that is exactly how you break out of the examiner's trap. Okay, now pay super close attention here. In just a moment, I'm going to show you the exact examiner clue that changes the answer completely. Seriously, it's the one detail that trips up even top-tier students. But before we get to that, you need the procedural framework that actually makes that clue obvious when you're sweating under the pressure of a ticking exam clock. Which brings us to section 3, the procedural success framework. So, if you want to capture those coveted partial method marks, the ones that literally save your grade when your arithmetic goes horribly wrong, you absolutely must follow this standardized processing sequence. Think of it as your shield. You can't just jump to a final calculation and hope for the best, right? Step 1, read and identify the key given elements. Step 2, select and apply the relevant calculus principles. Step 3, show and execute clear logical working. Step 4, check and verify your results to make sure they're actually reasonable. And step 5, present your final answer in the proper format. Skipping any of these, like, jumping from read straight to show, is exactly how the examiner springs the trap on unsuspecting candidates. You have to deconstruct, solve, and then evaluate. And wow, the difference between an amateur answer and a top band response is just stark. If you look on the left, the flawed answer is super vague. It's missing proper terminology, the working isn't shown clearly, and it totally ignores the physical context of how the particle is actually moving. But look on the right, that top band answer locks in maximum method marks for sure. It's got clear annotation, proper mathematical headings, and it connects the concepts directly to the context of the question. It basically proves to the examiner, hey, I'm not just crunching random numbers here, I actually understand the motion. Now, let's jump into section 4, principal examiner insights. To really beat this test, you've got to read your opponent. And we do that by looking at direct, critical analysis straight from the Cambridge principal examiner reports. Here are the top 3 fatal flaws that routinely shock students on results day. First off, answers are often way too vague. Examiners are practically begging for specific details. Second, candidates just completely forget to check their final format and presentation conventions. And third, and this is absolutely crucial, answers are not specific to the context given. Evaluative thinking means you have to identify assumptions and alternative interpretations based on the actual context of the word problem. Just listen to this direct quote straight from the source. Examiner alert. Candidates consistently confuse key terminology. Always define terms before using them in extended responses. This isn't just a suggestion, guys. Proper formatting and correct terminology are non-negotiable professional skills in the 0606 syllabus. Simply put, if you write down a variable, you better know exactly what physical state it represents. Okay, let's actually test that right now with a little interactive pause and predict moment. Take a look at this statement. A student writes, V equals 0 means the particle is at the origin, therefore, S equals 0. Now I want you to look really closely at that assumption. Can you spot the fatal error hiding right there in plain sight? Think about what velocity actually means in the physical, real world. All right, here is the examiner-style correction. When velocity equals 0, it simply means the particle is instantaneously at rest. It's kind of like a ball that you've thrown up in the air, reaching its absolute peak right before it falls back down. It absolutely 100% does not mean displacement is 0. I mean, that particle could be resting 10 whole meters away from the origin. Top-performing students exhibit this deeply connected conceptual understanding, and they can easily transfer it to unfamiliar contexts. And guess what? That right there was the examiner clue that changes everything. Context. And that leads us perfectly into Section 5, setting up the checkmate. So we've mapped out the trap, and we've basically stolen the opponent's playbook. Now, to secure those high marks and finalize your strategic position, you've got to execute these 3 main takeaways. First, master those SVA calculus relationships. You need to know in your bones when to differentiate and when to integrate. Second, rigidly lock in that read, select, show, check, answer procedural sequence. That is how you guarantee those method marks. And third, always define your specific terminology and evaluate your answer against the physical context of the problem. So you now have the exact framework to avoid losing needless marks. But knowing the framework and actually executing it against the absolute hardest questions, well, those are 2 very different things. Checkmate requires one final move. You have the framework, sure, but how do you solve the ultimate integration past paper trap, where the limits of integration just completely flip the context on its head? Make sure you subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations, and join us as we tackle that exact problem in our next explainer. See you then.